This is Electric Universe Geology, Earth News. We're going to talk about hydrology today, a few different aspects of hydrology. I just noticing this, I was looking at Lake Shasta and the Sacramento River that comes south of Lake Shasta right here, goes down into Sacramento, and then I noticed Trinity Lake, or Trinity Reservoir, which runs into the Trinity River, and I assumed, gee, this must go south and hook up with the Sacramento somewhere. Because these are big mountains, it wouldn't just flow right through a mountain chain. And lo and behold, as it turns out, the reservoir empties down here, comes up here, goes all the way through these mountains, all the way up to Klamath. I think it's right here. Let me zoom in. Yeah, this is the end of the river right here, going all the way through the coastal range of California. And the coastal range of California, according to Wikipedia, was folded and faulted. So this mountain chain would have folded and faulted, and then this river would have found its way there's Klamath right here. The river would have found its way all the way through, and I don't see a lake. I don't see one single lake. I see a smooth flowing river. The only place there's lakes is where there's a reservoir. That doesn't make any sense to me. So my position would be that this river was here first, and that these mountains grew around it. It has nothing to do with folding or faulting. I think that's an insane option because they didn't have any other options available. So they took all they had available to themselves. They didn't think that a mountain could grow from external material. Now we're going to look at some other angles of hydrology. In the comments section on the Seething River of Plasma video, a kind gentleman pointed out, and this gentleman has a background in geology, that there's really not enough water to make these cliffs, to erode this canyon right here. It's just seasonal drainage, and it's not much. It doesn't make sense. At its highest point, at the biggest flood of history, it wouldn't be that high if it was just seasonal rains and snow melt and that sort of thing. But that's not what we're talking about here. We're talking about a flood that went north, carrying with it thousands of feet of sediment, fresh, soft mud. The water goes north until the earth starts to rotate in the opposite direction. If this catastrophic scenario is accurate, the water stays north. But as the earth starts to rotate in the opposite direction, the water is sucked back to the equator, probably slowly at first. And as you get acceleration, it would be faster and faster. And when it's an inland sea or an ocean, as it were, initially you'd have a slow water current going towards the south, going back to the equator. But as the water recedes and gets lower and lower, eventually it would become the width of the entire canyon, and the water would be ripping through the fresh, soft sediments incredibly quickly. That's how you get these giant fluvial erosion canyons. Now, that's not to say electricity can't come along and modify this later, especially close to the Four Corners vortex. So it's a combination of hydrology ripping out a canyon as a inland sea retreats to the equator, and then you have electricity coming along and enhancing, modifying, heating, bubbling, and expanding some of these canyons, I believe. And that's what's happened in these areas. Staircase of the Escalante, Zion Canyon, are markers for this. And in other areas, not so much, less and less. But I think it's a combination. It's not just electrical excavation. It's not just hydrology. It's a combination of the two. And the only way you could get enough water to accomplish this is not with a seasonal flood, but with a retreating ocean going back to the equator. Thank you.